It's my turn now. Hello? Hello?
Hello? Yeah. Good morning,
You hear
Professor.
me? Okay. Thank you very much. First, I would like to thank Professor Tian Zhongqun invite me to give this talk. Maybe I am the only one from engineering field in this conference to talk about the excess energy from mechanical system. So the title of my talk is excess energy from heat exchange system. And my presentation is divided into 4 parts, and they include the up-to-date results from our research program, which focus on answering the question, can excess energy be induced from a simple heat exchanging process involving cavitation in kilowatt scale? First, I'd like to talk something about cavitation and its power. As you know, cavitation is a process of liquid vaporization at a pressure lower than thermodynamic vapor pressure, and then which generates bubbles and create implosion with intense shock wave and microjet, which can damage propeller by mechanical force or even heat. And the cavitation can also generate heat or light. For example, this is the data taken by 3 scientists. Once the bubble grows up to about 45 micrometer, then suddenly it collapses in 5 microseconds and create light. It means also heat. It's about 5,000 degree Kelvin, and then which may induce low energy nuclear reaction. So I did a very simple experiment at my home. I put the copper foil in a 30-watt ultrasonic vibrator for 7 minutes and 21 minutes. It happens in this way. You see the photos. It's so amazing. It's made by ultrasonic vibrator, and it got the material of copper foil. It's a break, and if you look at the failure mechanism, I think both mechanical and the thermal effect play the role in such a kind of damage. And if you look at the strength of bubble collapse from gas bubble dynamics, if the bubble size is 1 nanometer, the pressure inside, the pressure difference across the bubble will be nearly 3,000 atmosphere. And this can create a tremendous heat, the effect on the cavitation, on the something like the copper foil damage. And a company, New Energy Power System, who also support this conference, they invent a so-called cavitation engine, and they use a diesel fuel injector to inject a high-pressure water jet. It's around about 2,000 atmosphere pressure with a very high speed into a chamber to create cavitation and induce low energy nuclear reaction. This is they call it impact chamber. And then through the cavitation, micro bubbles which collide with the wall and create a lot of complex physical phenomena, and then produce excess heat. And this is their experiment results. the COP is 5.25 at 388 degrees C. This is amazing. The result is great. If the company continues to develop such technology and reach COP 10 with a temperature higher than 400 degrees using water as fuel, then the world is going to be changed. It's a new energy revolution. For example, if we put 100 megawatt heat into the machine, produce 1,000, then generate electricity 40% 400, then you got a net about 3 megawatt electricity. I think if this happens, then we don't need heater. So the following, I'm going to introduce the research of cavitation machines we did in Taiwan University since the year 2018. Because we are engineering people, we use engineering approach according to phenomena we observe. The first one is cavitation, as I mentioned, is cavitation power. And then the dynamic implosion during cavitation with narrow bubbles is also the key issue in such a phenomena. So we developed 2 cavitation machines for the past 2 years, and I'm going to present the result and to share with you. The first machine is we call the triple pipe heat exchanger. It's heated by vapor compression system. This result, part of result, has been presented in the ICCF-23 in Italy 2 years ago. And we continue to run the test, and the triple heat pipe exchanger is heated by a compressor with a refrigerant vapor, hot vapor, to heat the cold water coming through the heated pipe exchanger. And the water only flows through very teeny passage. The passage is only about 1.6 millimeter gap. So within the passage and also the heat from the refrigerant vapor, it's about 150 degrees. Then must be some severe cavitation happens inside the passage. And according to energy balance, the heat output from the water equal to input minus heat loss. So this is the first law of thermodynamics. And we developed we call water flow calorimetry to measure the net water output energy, and define we call excess energy index. And the water flow calorimetry is quite a very simple heat transfer method. We use a tank containing cold water with mass and the temperature, also internal energy. Then we keep the water flow from the heat exchanger and then heat up together. And finally, you've got a mass and the temperature, and the experiment terminates before water is boiling. And then you just did the energy balance calculation and calculate the net energy output from water. And the energy balance, as I have already mentioned in last slides, the first law of thermodynamics is like this. I define an excess energy index, use energy output as a numerator and the energy input as the denominator. It's the first law of thermodynamics. If nothing special, then COPx should be 1. If something happens greater than 1, will result in you can judge whether there's an X heat or not. It's quite a simple device and easy to operate. And we run the test for about 2 years under various operating conditions. the test result shows excess energy exists like this. Only one special case here. And can be repeated. The machine has been run for 2 years, and the COP ranges from 1.29 up to maxima about nearly 2. But unfortunately, the compressor is made by Qwnet company, USA, breaks down at the end of year 2020 due to overheating. Then we replacing the compressor with the new models, and the compressor it was very old-fashioned. It's a phase out, so we changed with new compressor, but something in strength, it never returned to the performance as we did before. COP decreased a little bit, and this is the test result we obtained for the past 2 years. And COP, if COP less than 1.2, then we can determine that there's no excess energy. 1.2 means we take into account the experimental error is worst case, about 20%. And then if we plot COPx with inlet water temperature, it's interesting. There's some relationship. COP related to temperature gradient of the two streams. The higher inlet temperature means the lower temperature gradient between the two streams. It's water and the freon. So it means weak cavitation. If higher, that means stronger higher cavitation. Then you got a higher excess energy. And I'd like to share with you about some peculiar phenomena we observed. The output steam temperature in the heat exchanger here is it's been heated from cold to hot. And suppose it should be lower than the heat source refrigerant vapor, but we find it's lower, it's higher than refrigerant vapor temperature. So that means some excess energy was generated in water, and instead the refrigerant vapor is not cooled, it's heated by at some part, especially this part, exit part of the heat exchanger, it's heated. So it's quite strange. And then the second, we found that there's abnormally high waterline pressure, larger than 50 bar, that damaged break the pressure gauge. That implies cavitation bubble size may be around 50 nanometers according to the bubble dynamics. And also, the cover pipe was cracked and the leak. This is the second peculiar phenomenon we observed. The third, there's a serious falling happens even in a day, causing blockage of water passage. That overnight, you found the water passage was blocked by falling scale. So it's quite strange. Usually, falling happens in heat exchanger, in boiler, but should not be so fast in a day, overnight. The last peculiar phenomena I'd like to mention is the refrigerant oil of the vapor compressor seems to play some role in heat transfer inside the triple point heat exchanger, and it causes interesting heat transfer phenomena. Just like behavior of oscillating heat pipe, the heat transfer behave oscillating effect. It's back and forth and they oscillate, and causes also the excess heat. And the second machine I'd like to mention is we call double pipe heat exchanger, heated by steam, not the vapor, not the compressor freon vapor. And the double pipe heat exchanger design, we use—
Mr. Wang, you have 5 minutes more.
Okay, no problem. And we use a steam boiler as the heat source. in that case, the machine can be easy for large-scale applications, and also double pipe heat exchanger reduce manufacturing costs, and also the energy index, excess energy index, also defined as output divided by input energy, and also the same. And we run experiment for since last July, and the fourth month we get nothing special until November. It suddenly, because we changed the operating condition, operating condition, like flow rate control, vapor pressure control schemes, and we found that COP goes up suddenly. The highest value is 2.6, and the cavitation bubble size is estimated 20 nanometers. And unfortunately, at the end of the year, the pipe rupture and the leakage. So we changed another new heat exchanger with stronger structure, but we cannot repeat the test results of the first one. And the COP equal to 1, the data can be treated as a baseline calibration of the test bed. So this shows the excess energy heat generation from 2 to 4 kilowatts. And some peculiar phenomena I'd like to share with you. First, the inner copper pipe, and we cut it in pieces and examine, find that originally copper pipe called concentric is a double pipe exchanger, but after crack and leak, we inform that we examined that and found that there's a pipe buckling like this. And if the buckling is caused by pressure, then the pressure must be higher than 160 bar. Or if it's caused by high temperature, then it must be higher than 500 degrees. Otherwise, it cannot happen like this way. So this is the result we found. And we do an element chemical analysis and found that original copper pipe has a copper and the carbon 5%, but for the after buckle rupture, the carbon compound increases and also oxygen increases. And the buckling, this shows the buckling and the shining black surface after the phenomena. And finally, we go to SEM exam, and we found very interesting. The pipe surface looks like a copper oxide and narrow wire. And we check with literature if copper oxide is produced, narrow wire produced on copper foil, it should be about temperature 500 to 700. That means the buckling phenomena may be caused by high temperature inside the heat exchanger. So this is the result we found very interesting. And
Professor Wang, where
okay,
one
last one.
Okay.
So the conclusion is that excess energy in kilowatt scale can be induced from simple heat exchange process involving cavitation. The test results shows that excess heat exists, and the excess energy index can be used to identify the existence of excess energy phenomena. And the fourth, I'd like to mention, the materials problem will be eventually encountered for the machines with excess energy, since extremely high pressure or high temperature will be induced. The phenomena of COPx larger one is related to cavitations, and that more research by scientists are needed. As engineering people, we are focusing on the duplication of the best performance obtained during the study to provide a reliable, simple, and cheap machine to harvest energy from water. The current task is try to repeat the best results of the first one and leave the materials problem to future and engineering development. I hope this I mean the dream of tomorrow come true like this. Thank you very much.
Thank you, Professor Wang. I think that we have already used the time for discussion, so now is scheduled the next